In the quantum world, particles have various possible states that only come into existence when we observe them. However, objects we see in our everyday lives have definite states that typically remain the same even when we're not observing them. So what makes quantum objects so much different? To find out, let's begin with a quantum particle, like a photon. Like all quantum particles, our photon can exist in various possible states. When isolated from the environment, we are able to observe these states. But what if our photon starts interacting with the environment? As the photon collides with other particles, it links together with them. You can think of this like the photon attaching a string between the two particles. Now whenever a photon takes on a new state, the linked particles also take on those same states. When the linked particles collide with other particles, more particles get linked to our photon. This continues to happen until the entire environment is linked together. But if the entire environment is linked to our photon, why isn't the environment taking on various states? Well, actually, the environment is taking on various states, but we can't observe them because we're taking on those states with it. You can think of this like riding on an airplane. From the outside, you can see that the plane is moving, but from the inside, it feels like the plane isn't moving at all because you're moving with it. Because the rest of the environment, including us, now share the same states as the particle, we can no longer identify quantum behavior in our particle or the environment. And that's quantum decoherence. Decoherence can disrupt processes in quantum computers, which rely on particles' quantum behavior to perform calculations. Decoherence is also what makes our world go round, instead of all over the place.